Alright guys, today we're going to talk about we're going to talk about crisscross method and nomenclature, binary compounds, binary meaning two. So we're going to be naming compounds which feature at least two element atoms. And first of all, before we even get into this and dive into this, I want you to make sure that you learn your ions. You must learn your ions. That is probably the most important thing you can do. And so, in the early stages, I talk about how if you're looking at the ionic form of compounds, if you just look at your periodic table, that first group, everything in group 1 is going to be a plus 1 or form a plus 1 ion. Everything in group 2 is going to form a plus 2 ion. Most things in column 3 are going to form a plus 3 ion. Your carbons can do kind of some interesting things. Some of them are plus 4. We'll learn about 10, which is actually plus 2 and plus 4. Lead is the same thing, plus 2 and plus 4. Carbon does some interesting things. Nitrogen, that one's going to be generally either a plus 5 or a minus 3. You want to kind of, depending on what it needs, it can actually adjust. Same thing with this phosphorus. Sulfur does some spectacular things. Oxygen is usually minus 2. Sulfur can be minus 2 on many occasions. Selenium can be minus 2. Fluorine is going to be your minus 1s. Chlorine, minus 1. Bromine, iodine forms minus 1. And remember, that's because they lose electrons. And then your noble gases, you don't have to worry about these guys forming any ionic compounds and forming any kind of complex compounds because they generally are inert and they don't usually react that often. So let's go ahead and get right into it. That was your basic chemistry recap, but all in all, you do need to learn your ions. Those are some basic kind of entry stuff that we talk about. And so, looking right at it, I want to get started with looking at this sheet. And this is called crisscross method. Some people call it charge balancing. And it's the least math-focused part of chemistry, I would think, but it still kind of requires it. I think it's very approachable. Now, what it does is the crisscross method basically says if you know the ionic form of that compound and you know the ionic form of that compound, when they merge to form a compound, the 2 goes here and the 3 goes here, and they're dropping their numbers, which were once superscript, and now they become kind of subscripted there. Now, from a structural arrangement, this means that to balance them out, you ended up with 2 atoms of this aluminum, which has a plus 3 charge, for a net plus 6, and that's balanced by 3 atoms of this oxygen, which has a minus 2 charge, which ends up being being negative 6. Negative 6 and positive 6 equates to neutralization. That's represented here. You don't necessarily need to know all that. It helps to have that as a foundation because it helps with mastery of charge balancing, but part of it just understanding is knowing the ionic structure and then kind of going from there. So we're going to look at some practice ones without diving too deeply. And recall I mentioned how if you know your ions in your periodic table, you kind of have an idea of the charges that they contribute. Now, barium is found in column 2, I believe. Let me fact check, which I really don't need the fact check, but you might want a periodic table in case. But ion charts are definitely not provided, but I do know that the periodic table can be your friend in this case. Aluminum is going to be plus 3. Lead is going to be plus 2 unless it's otherwise evidence says plus 4. This iron is indicated by plus 2. This iron is indicated by plus 3. Fluorine is minus. Oxygen is 2 minus. Phosphide in this case is going to be 3 minus, or minus 3, same thing. Minus 2, minus 1. In this case, your carbon is going to do some interesting things. We can use it as a minus 2 or minus 4. Depends on the need. Selenium is going to be minus 2 definitely. Chlorine is going to be minus 1. And so, looking at those, we're going to create some of these compounds and we're going to determine how they contribute to forming these compounds of a binary nature. Binary being 2, like I said. Now, if I didn't already highlight, I need to distinguish this word cation and anion. Positive charge ion, negative charge ion. And whenever you name these, you start with the cation name first, and then the anion next. So naming them, that's what you do. So let's go ahead and get started, and we should look at maybe that first column where we have kind of fluoride. And so let's look at that. We'll look at carbon as -1 in this case. All right, so -2 and +2. What this originally looks like is you take your Ba +2, and that goes on the fluorine side, and the 1 goes on the Ba side, so you end up with a product that looks like this. If I'm going down, Al contributes its 3, and then F becomes this. Now, I'm not indicating what this minus is doing, but it's actually representing a 1, and it's going down to the cation subscript. But you don't usually represent that 1 subscript when you're representing your answer. So let me go ahead and continue here. We're going to assume that we're operating using lead 2+. We'll do this. And if we were doing lead 4+, it would be this. Moving on, F minus, Fe2, that'll be Fe and F2, Fe and F3. Alright, so what's going to happen next is we're going to go down that column featuring oxygen, and we should notice that, interestingly enough, the oxygens actually do some interesting things where they simplify based on their common number of subscripts. So if you have a number kind of like this, where you have lead +4 and oxygen 2-, they combine to form lead 2, oxygen 4, but you simplify these, common denominator, that's divided by 2, that's divided by 2, that ends up 1 and the 2. We're going to do that in some of these here. So for this one, it starts off as Ba2O2, but they simplify and become BaO. Here we have aluminum 3+ and oxygen 2. The 2 comes over here. The 3 goes over there. And that's kind of like the example we talked about. It's exactly the example we talked about. Here you have your lead. And if we were using lead 2+, it would be lead 2O2. Those would cancel out and look like this. And you've seen the example where it's lead 4. Here, same rules apply. Fe2O2, they both cancel out and become FeO. Here you have Fe, that 2 comes here, and then that 3 goes there. Next we have our phosphides where we have a 3. This becomes Ba3, P2. This starts off as Al3P3, but they cancel out and become AlP. Assuming we have lead +2 to begin with, this becomes Pb3, P2. Here we have Fe3, P2. And lastly, we have Fe3, P3, which cancels out and becomes FeP. We're going to move on and look at this column where we have a -2 again. Once again, we have these 2 guys, which cancel out and become this. barium sulfide. And maybe I should go ahead and say some of these names so we can start getting that in our memory, our repertoire. Barium fluoride, aluminum fluoride, lead 2 fluoride, iron fluoride or iron 2 fluoride. You only indicate the Roman numeral or the number when there's more than one ionic species. This is iron 3 fluoride, barium oxide, aluminum oxide, lead 2 oxide, iron 2 oxide, iron 3 oxide, barium phosphide, aluminum phosphide, lead 2 phosphide, iron 2 phosphide, iron 3 phosphide. And then this is barium sulfide. And then moving on, we have aluminum sulfide. We have lead 2 sulfide, which becomes this. We have iron 2 sulfide, which becomes this. We have iron 3 sulfide. So hopefully we're starting to get the hang of these guys and understand kind of the trend that's going through here. We'll do one more and just kind of close it off with that, just because I think we've started to get a general understanding. Here, your bromine is going to be Ba1, Br2, and that's barium bromide. Notice the anions, these guys, just assume an "ide" suffix, and then the cations just maintain their status quo of their original names. So aluminum bromide, lead 2 bromide, iron 2 bromide, iron 3 bromide. And so with crisscross method, all you're doing is crossing the numbers. And just with a little bit more practice, you'll become familiar with distributing the charge and understanding how they create these new compounds. And so that culminates today's lessons. I think we've gotten the point across when it comes down to the practice problems.